Hi everyone, my name is Julian Alberio, this is Mark Chumacon and Justin Tunis, and we're part of the Laser Snooper team, or we are the Laser Snooper team. And so basically, what is a laser snooper? A laser snooper works on the idea that when humans talk, we cause the objects around us to vibrate, and so this includes doors and windows. Theoretically, and what we've produced, when there's a window vibrating due to human conversation, you, from the outside of the room, can shoot a laser at the window and then have a receiver that picks up the reflection of the laser from the window and outputs the oscillations in the position of the laser as audio. So we'll go over in just a minute how exactly we made this, and we'll show you a demonstration of it working also. And additionally, we also produced direct laser to receiver communication just using the modulation of the laser. All right, so we're going to head on over here to our setup. And so this is our current setup that in just a moment we're going to use for demonstrations. But as is right now, the first part, so we can see right here, this is a laser, just a standard color red laser for testing purposes. It shoots over here to a box that has a little mirror on it. This is to emulate a window, just because the windows we have here are a little dirty. And then it reflects back over to here, over to our laser diode, where you can see it sticking out of our circuit right there. And then that goes into a transimpedance amplifier, which, as we did in some of the labs, effectively what a transimpedance amplifier does is it takes a very, very small signal that we have, which will be coming from the oscillations in the position of the laser, and how much current this photodiode is producing, and it magnifies that. And what's good about our current transimpedance amplifier design is that it does a lot to help remove the common mode gain, so a lot of gain that's going to be coming from ambient sunlight and just the lights above us. And so then our transimpedance amplifier sends that signal out to our filtering, which Justin will talk about now.
Okay, so the output from the transimpedance amplifier is sent to a third-order high-pass filter cascaded with a third-order low-pass filter, both Sallen-Key topologies. And basically, the fundamental frequencies of speech are in like the hundreds of dBs, but what humans really hear are usually the third and fifth harmonics. So our voice bandpass filter is, the pass band is from 300 hertz to 3 kHz, which is where humans like really hear this speech. And because there's third order on both sides of the bandpass, we have a minus 60 dB per decade fall off outside of the band, which means that it attenuates outside noise very, very well. And then the output from that is sent to our amplifier.
All right, so the last part of our system is basically the audio amplifier. So once we've received and amplified the signal, filtered it with those two circuits, it comes over here onto this side where it goes through a buffer and gaining stage, and then an amplifier, a Class B amplifier to be specific, which is fed over there to that speaker. And so basically the entire system put together will have audio coming in from the laser snooper over there, and then we can hear it in that speaker. Another additional part that we added to our circuit was just this laser diode right here, and a simple circuit with this aux cable connected to it. So the idea is if we hook up a phone to this aux cable, we can modulate this laser, and later we'll demonstrate basically shooting this laser directly at that diode to get the audio signal out on that side of the speaker. And yeah, we also had a Class D amplifier for the audio, but currently it is not working, it's fried, and so we're just going to run it with the Class B.
Alright, so as you can see, I'm actually over here by this box, actually providing a demonstration of the laser snooper. So what's actually going on right now is my voice is causing this box to vibrate, and as the laser shoots over here at this little mirror in the box, and then hits this photodiode right here, it's picking up the oscillations in the position of the laser because due to the oscillations in the box. And so that's how you're able to hear me, even though I'm talking with this box. The audio is coming out of that speaker right over there. And you actually have to keep it pretty far away from our box just to avoid feedback. Because the feedback actually gets pretty loud. And so that is sort of a proof demo of our laser snooper.